This is Algebra 2, the practice test for number 7, a practice test for Unit 7, I should say. In number 1, it's in vertex form. Again, notice that there's these numbers up here that tell you what lesson this is from. This is from lesson 7-1. I'll write out the instructions on essentially what you're supposed to do. If it's a number that's close to the x, that's going to affect you in the x direction, mainly the left and right direction. And if it's a number out not by the x, it's going to affect the y direction, the up and down direction. The up and down direction, there's nothing to it. -4 means down 4. So this is down 4. And when it's inside of the parentheses or anything next to an x, very commonly it's the opposite. So normally you'd think, oh, that's left 3, but it's the opposite. So it's going to be actually right 3. So that's going to be the vertex. You go right 3, down 4. Right 3, down 4 is our vertex is right here. And then remember our pattern. Our pattern for quadratics, it has this weird thing that goes 1, 3, 5, 7. It's all these odd numbers. So right 1, up 1. Right 1, up 3. And then there's this axis of symmetry. So there's this symmetry. And then you have points over on the other side as well. And there's our graph. So we're going to go ahead and make a gentle curve that comes through these points, and it goes up forever and ever, so we have arrows on it. Number 2, kind of the same thing. I'm going to go ahead and label this one. When I have +1 on the inside, that means I'm actually going left 1, and then this is going to be up 2. So left 1, up 2, a vertex is right here, and again, the same pattern, right 1, up 1, right 1, up 3, right 1, up 5, and I'm off the graph. Axis of symmetry, and I have my graph. So let's go ahead and make our parabola. And done. Number 3. This one is a little bit harder. This is from lesson 7-2. So again, it's kind of the same idea. The vertex doesn't change. I'll go ahead and label it. This is going to be right 4 and down 4. So go right 4, down 4, and that's going to be your vertex. And then normally the pattern is go right 1, up 1, right 1, up 3, right 1, up 5. But because we have this multiplier by 2, our new change is going to be right 1, up 2, right 1, up 6, right 1, up 10. So right 1, up 2, right 1, up 6. Is that going to be off the grid? It's going to come up here to 4. Again, I just did -2 plus 6, and I got 4, so I need to come up with this height of 4. And then I'm going to use this axis of symmetry and make points over here on the left-hand side. And again, it's going to be a very steep parabola. And coming down here, it's supposed to be a gentle curve down here. It's not supposed to be a point, but it's hard to do when it's so steep like that. And number 4, kind of the same thing, where you're going to label this one. If it's inside next to the x, it's going to be opposite. So +2 actually means left 2, and -2, there's no opposite. This is just down 2. Down 2. So left 2, down 2, there's our vertex. And normally it's right 1, up 1, right 1, up 3, right 1, up 5, but we are now going to be multiplying each of these numbers by this number, which is -1/2. So I'm actually going to be doing right 1 down 1/2, and 3 times 1/2 or -1/2 is -1.5, or if you prefer -3/2. I prefer the decimals in this case because they're easier to see. And then down 2.5. So instead of going up, I'm going down. So I'm going to go down 1/2 when I go. So here I go. I'm going right 1, then down 1/2. And then axis of symmetry. And then from there, I'm going to go right 1 and then down 1.5. So right 1, down 1/2, and then another 1, giving me this point down here. And axis of symmetry. And then going 2.5, you can see that this distance is 2, so 2.5 would be down here a little bit, which is off the graph, so we're not going to worry about it. And we're going to make our graph. There's our parabola. There's our parabola. Yeah, good enough. Number 5. So in these, they're not in vertex form. You need to complete the square to turn them into vertex form. So I'll do an explanation for number 5, and I'll kind of go through number 6 a little bit faster. The general idea behind number 5 is you have to complete the square. You have an x squared, you have a 4x that's equally divided here and here, so 2x and 2x. And then you're filling in the sides. The sides are going to be x times x gives you x squared, and x times 2 gives you the 2x. So there's a positive 2, I guess you can put +2. A +2 here. And what number is missing here to complete the square? Well, 2 times 2 multiply here to 4. That's the number that's missing. Notice that this is not a 4, so make it a 4. There's a few different ways to do it. I like the lazy way of doing it and just saying, there it is, +4. But normally what we do is we add 4 to the one side and add 4 to the other side. You can't add 4 to the other sides. The only thing that you're left to do is, well, I can add 0. That doesn't change anything. I added 4, so I can also subtract 4, now I've added 0. Like, this is the same thing as not doing anything. And let me show you my two groups. Here's the first group. In this group, this is the inside of our square, right? X squared is right there. 4x is right there. 4 is right there. That's the inside of the square. And the inside of the square came from x plus 2 times x plus 2, or namely, that was x plus 2 quantity squared. And then I had this other leftover piece, this plus 1 minus 4, which is really a minus 3. And now this is in vertex form, so I can graph this. This, again, I will say plus 2 is left 2, and then minus 3 is down 3. So go left 2, down 3, and it's going to be down here. And whenever I have these completing the square problems, because we're not in an honors class, there's no number out front like a 2 that I have to worry about, so it's still going to go up 1, 3, 5, 7 by those odd numbers. So right one up 1, right one up 3, and by then we're going to be off the graph. Use this axis of symmetry to get this other half, and there's our parabola. Shwink. Nice. So I'll do the shortcutting method in number 6 so you can see it. Oh, I happen to give another 4. I probably should fix that in future years to make this a little bit harder. The general idea is take half of it, square it, add and subtract it. So half of 4 is 2. Square it goes back to 4. And then I'm going to add it to both sides. So I'm going to add 4 right there, and, well, not to both sides. I can't do both sides, so I have to subtract it from the other side. There you go. So there's my first piece, which is going to be x plus half of that term, which is 2 squared, and plus 3 minus 4 is the same thing as minus 1. And again, this is going to be left 2 and then down 1. So left 2, down 1, our vertex is right here. And there's no number out front because we're not in an honors class. And I'm going to go right one up 1, right one up 3, right one up 5, and then it's off the graph by that point. So I have my completed parabola. Ooh, missed that last point. Try it again. There we go. And arrows to say it goes on forever and ever. Lesson 7-4 gives us problem number 7. This is kind of the same thing. This is in vertex form. The only addition is you have to shade a piece of it. Remember that this doesn't mean inside or outside. It means up or down, above or below. So again, I'm going to go ahead and annotate this thing. Minus 1 means right 1, and plus 4 means up 4. So right 1, up 4 gives us this vertex right here. And normally I'd be going right 1, up 1, right 1, up 3, right 1, up 5, but now I'm multiplying each of these numbers by that number, which is really negative 1. So really I'm going to go right 1, down 1, right 1, down 3, and right 1, down 5. Right 1, down 1, right 1, down 3, right 1, down 5 is going to be off the graph, and use the axis of symmetry to complete the quadratic. Arrow comes down here, arrow, and then finally I do this symbol. Oh, by the way, if this was there's no equal to sign down here, like if this bar right here didn't exist, it was just this symbol, then I would have had a dash line, but I have a solid line. In this one I'll have a dash line. And this says less than. Less than means underneath. Underneath this line is down here, and I can shade that in. Pro tip, if you guys have a highlighter, use it. Like, the highlighter is going to make your life really nice. So here's my highlighter. Try to make it. Yeah, I went over the lines a little bit. Yeah, there we go. So all of this area down here will be shaded. Nice. What about number 8? Kind of the same thing as we were doing in problems number 5 and 6 up above, where you have to complete the square. This is even easier because there's no there's no number out here to add or subtract. So completing the square, man, I gave a bunch of 4s, didn't I? I really need to fix that so you're not doing the same thing over and over again. General idea here is half of this negative 4, again, negative 4, is negative 2. When I square that, and it's 4. So I need to add 4 here. If I add 4, I also have to subtract 4. Remember that all of this thing is going to turn into x squared minus 2. What am I saying? X minus 2, there we go, quantity squared. And then I still have this minus 4 leftover piece. And annotating this thing, minus 2 means go right 2, and minus 4 means down 4. So right 2, down 4 is going to give us this vertex down here, and there's no number out front, so it's going to be that same right 1 up 1, right 1 up 3, right 1 up 5, axis of symmetry, and we graph this. Cool, and I messed up, didn't I? Undo, because it's not a solid line. This, I said it before, this is a not equal to, so I need to do a dash line. So let me do my dash line that comes down here, and arrow that goes up, and then I decide where to highlight. Notice that I have a less than, which means it's underneath. Underneath is going to be shading in like so. I'm going to shade in underneath. I'm going to try to get as close to this line as possible. Shading in underneath, so it's everything in this area here is fair game on the graph. Everything right here. That's everything that's not above the parabola. Cool, there it is. And then we move on to number 9. And number 9 from lesson 7-5, we're just factoring. And this is a nice one because there's no leading coefficient here. Can I divide each of these numbers, each of these terms by a number? And the answer is no, so there's no GCF, greatest common factor, to factor out. I jump straight into, we use the tool, the ninja star. We can say, okay, what two numbers add to 17? So this is the add number. And at the same time, multiply to 72. So this is the multiply number. And I usually start with the multiply number. So, and I think I'm going to go ahead and pull out the, what is it, the multiplication chart. So let me come back here. I'll show you how I do things. I'm going to go ahead and import something from my drive. I'm going to go to work, and I don't remember where I put it. It's something like M for multiplication chart. That would make sense. Let's go down to M, LM, multiplication, multiplication table. That's the one I want. So let's go ahead and open U. That way you're just close by, and I can move this page right here. So that way I need to figure out what multiplies to 72 and also adds to 17. This is how you use the multiplication table. We're trying to find multiples of 72. So when I'm looking in here, I'm seeing, here, let me mark it up and I can always erase it, right? I have a 72 here, and they need to add to 17, and I got lucky my first time. 8 times 9 is, or sorry, 8 plus 9 is 17, so I was done. But maybe you're looking around, you're like, oh, there were a bunch of other 72s. There was that 72, there was that 72, there was that 72, there was that 72. There's a bunch of different 72s. I just got like in the first one. And this is the correct one. It is 8 and 9. So I come back over here. I say the numbers 8 and 9 multiply to 72, and they also add to 17. And then I finish completing the square. I say B, it's a positive 8, and B, it's a positive 9, so plus 9. And I've done my factoring. Box it. Final answer. What about number 10? Notice that each of these can be divided by a number. So this can be divided by 4, divided by 4, divided by 4. That is the greatest common factor, which means 4 is factored out, and I can figure out what's left over. I have an n squared minus 4n minus 60. Again, I just kind of hid the 0. 24 divided by 4 is 6, and I added the 0 back on to get 6, 0. All right, so now I'm going to ignore the 4 for a little bit, and I'm just going to set up a ninja star for this thing. So I'm going to do it off to the side. I'm going to say, what two numbers add to negative 4? Again, this is the add number. They add to negative 4, and at the same time, they multiply to negative 60. And whenever you have a negative up here, you know that one of these is going to be negative and one of them is going to be positive. There's no other choice, which means if one is negative, one is positive, and I'm trying to add them together, you're really doing a subtraction problem. So that's a long-winded way of saying if there's a minus, subtract the numbers. If there's not a minus, then you add the numbers. They might both be negative, but you still add them because they'll be the same sign. So let's look for 60, and when I subtract the numbers, I should get 4. So look for 60 over here. So let's go ahead and erase these. So we're looking for 60. And my eyes are first drawn to this 60. When I subtract them, I'm supposed to get 4. God dang, I got lucky again. Look at this. 6 and 10. 10 minus 6 is 4. But you could have seen a bunch of other 60s and been like, oh, but I saw this 60 first, which 10 and 6, which also is 4. Is there another 60 on here somewhere? There's this 60 that doesn't work. There's a 15 and 4. Those subtract to 11. But yeah, both of these 60s are correct answers. There's always 2 answers on every one. Again, the reason that there's 2 answers is because there's this diagonal squares that are always in bold. So the answers are kind of mirrored over here, and this 60 over here. These 2 are also mirrors of each other. So when I'm doing this, I typically don't look at the top piece. I'm looking at this piece underneath this line that I'm making. So all of this area down here is what I'm looking at. Anyway, the answer is 10 and 6 using our multiplication table. So I come back over here and say, this is supposed to be 10 and 6, and I know that when I add them that I take the sign of larger, which means larger needs to be a negative. This is larger, which needs to be a negative. And I'm ready. I can rewrite that 4, and now my variable is n, not x, and I have an n minus 10, and I also have an n plus 6 for my final answer, which I will then box. What about number 11? Can I divide each of these by a number? I think 5 is probably a good number. Yeah, so divide by 5, divide by 5, divide by 5. So the greatest common factor here is 5. I'll pull that out. When I divide each of these by 5, I'm left with a 7x squared. And if you don't know your trick for dividing by 5s, let me show you something cool. Dividing by 5 is the same thing as dividing by 10, aka moving the decimal place, and multiplying by 2, because 10, I don't know, divide by 10 times 2 is the same thing as divide by 5. I don't know how to say that, but yeah, so move the decimal place, so change this to 18 and then double it. 18 times 2 is 36. So the answer here is going to be minus 36x. And then kind of the same thing, this is 180, so this has to be a minus 36. So be careful here. This is the first time that after we factor out the greatest common factor, we still have a leading coefficient that's a number other than 1. So we have to be careful. This is going to be an advanced ninja star. I'll set this up off to the right-hand side. Whoa, I don't know what's happening. So again, they add the two numbers here and here are eventually going to add to negative 36. That hasn't changed. But here's the problem. You do not write negative 36 here. I was about to write negative 36. A lot of people think, oh, that negative 36 just comes up here. Remember, you're always multiplying the first number and the last number to come over here. And that actually makes sense over here because the first number here is 1. 1 times 72 was 72, and it makes sense over here. 1 times negative 60 is negative 60. It's just you forgot that you were always multiplying by that 1 out front. Now we have a number other than 1, so 7 times negative 36 is a number that I'm going to use the multiplication table for. So 7 and 36. What do we have? Let's go ahead and erase all of you. 7 and 36. So there's 7, and then 36 is down here, so 7 and 36 is 252. All right, so we're looking for 252. Let's come back over here. This is 252, and we also use this leading coefficient, so it's going to be 7x. So I have a 7x, 7x. Just set up my ninja star, so I'm ready to factor later. I'm looking for 252, and because this is a positive, oh, it's not a positive. Look, a negative times a positive should have been a negative. Because we have a negative, we know that we're going to subtract the numbers and get 36. So what minus what gives us 36? And I'm, again, looking for 252. So come back over here, search, find Waldo, 252. And they typically follow this pattern that goes like this. So that's where my eyes kind of lead, 252. So I see a 252 here. I see a 252 here. I see a 252 here, and by the time I hit this wall, I stop looking. That's why I made these numbers bold, so they're easier to say, hey, stop looking once you hit that wall. Okay, remember, when we subtract them, we should get 36. So subtracting these numbers to give 36, this one doesn't work because it's 14 and 18. When I subtract those, I get 4. I have to move really far away. Let's try this one. Well, that's the one that we started with, so that's probably not it. Let's keep going down. Again, it kind of follows this pattern down here. So 252 is right there. Does that one work? Let's see. That's going to be, what's the number up here? 6 and 42. Oh, that one does work. 42, and that goes all the way up here to 6. So 42 and 6, check it out. If I do 42 and 6, 42 minus 6 is 36. But again, we want to keep when we add them, we take the sign the larger. So the larger here has to be a negative. There we go. So it's a negative 42 and a positive 6. And now what I can do is I can reduce my fraction. So 7x over 6 it can't be reduced. So I can leave this as 7x and a positive 6. Well, that was a terrible parenthesis. And don't forget the 5 that's still factored out. And then what's going to happen over here? Well, this is a fraction that can be reduced. So if I think of this as the fraction 7x over negative 42, I can divide both the top and the bottom by 7. When I do that, I get an x on the top and a negative 6 on the bottom. And I can say this is x minus 6. And just to kind of sanity check, positive 6 times negative 6 gives us a negative 36. So that seems to work. I'm going to go ahead and box this. And moving on to number 12. These numbers are getting big. I'm seeing 54. It's divisible by 2. Is it divisible by 4? I don't think it is. I think the only thing we can do here is a 2. That means that we're going to have gigantic numbers still. I'm hoping I'm wrong. If I factor out a 2, that means I'm dividing each of these by 2. That's the greatest common factor. It's not that great, is it? That's going to be 27k squared minus 126k plus 120. Oh my goodness. Does our multiplication table even go that far? I don't think it goes to 120, does it? It doesn't. Well, we're going to have another method here that we can use. I'll show you how to use a calculator on this one. My goodness. All right, so from here, I'm going to, again, set up my advanced ninja star. Again, I'll start with these numbers here, which is going to be 27k. 27k 27k, 27k. I'm just really thinking, like, is there, yeah, 27 is not prime, that's a 3. Can I factor out a 3? I can factor out a 3, can I? Yeah, I can factor out a 3. Okay, I could have factored out a 6. Whew, I was really worried there for a sec because these are gigantic numbers. I usually don't do that to you. I was going to apologize, but I was still thinking in the back of my head, there's got to be a better way. You can divide by a bigger number. And let me talk about why I knew that, because that's kind of important. If you add these numbers, you can check for divisibility by 3. So for example, 2 plus 7 is 9, and 9 is divisible by 3, therefore 27 is divisible by 3. 1 plus 2 is 3, 3 plus 6 is 9. This is 9 when I add the digits, which the digits of the number, therefore this is also divisible by 3, since 9 is divisible by 3. 1 plus 2 plus 0 is 3. 3 is divisible by 3, therefore all 3 of these can be divided by 3 yet again. So I'm going to go ahead and do that. Divide by 3, divide by 3, divide by 3. And that means I have a 6 factored out. Why? Because I factored out 2 from you, and I factored out 3 from you. So 2 and 3 make the 6. What's left over? I have a 9k squared minus, okay, well, this is what I'm thinking in the back of my head. I'm thinking like 120 divided by 3 is nice, because I know that 12 divided by 3 is nice. And I know 120 divided by 3 is the same thing as 12 divided by 3, which is 4. I just needed to add on an extra 0, so 40. But the problem is I have this extra 3, or 6, so 6 divided by 3 is 2, so it's going to be 42. 42k, and then plus 40. All right, and just making sure I can't divide. Okay, your factors are 3 and 3. Can you be divisible by 3? Let's check. 4 plus 2 is 6. 6 is divisible by 3, so I might be able to divide by 3 again. Divide by 3, divide by 3, right? The problem is, no, you can't divide 40 by 3. Here's why. 4 plus 0 is 4, and 4 is not divisible by 3, so I think that's as far as we can go. Now we can set up our advanced ninja star, and these numbers are much more manageable. So I have a 9k here, 9k here. Where did those come from? That came from you and you, 9k. Negative 42 is going to come over here, so negative 42 is what we add to. Cancel. This is going to be what we add to, and what we multiply to is going to be up here. And again, that's going to come from 40 times 9. Again, when you have 40 times 9, kind of ignore the 4, or ignore the 0, and just do 4 times 9, which is 36. 36, and then add the 0 back on. We did a positive times a positive, so our answer is also positive. Everything's looking good there. So in our multiplication table, because this is a positive, we're looking to add numbers and somehow get 42. So looking for 360, and then when we add their factors, we get 42. Looking for 360, that was the main point. So let me get my eraser. 360, find 360. So I'm looking here, 360. I see a 360 here. 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 Do you guys see the pattern that I'm looking like? I'm looking at this pattern. I know it kind of moves down a little bit. I'm looking for a 360 here. 360 is almost off the graph, 360, and it's down here, which I can't see anymore. So it's got to be one of those, I'm really hoping. What was I looking for? Okay, we look for 360, and then after that, they should add, because this is positive, they should add up to 42. Technically negative 42, but add the factors, you get 42. Let's check. 18 and 20 add up to a 38, close, so it's probably close by. Let's see, 15 and 24, what was that, 39, it's close to 42, okay, about 12 and 30. That's 42 exactly. So it's 12 and 30. There it is. So this is going to be 12 and 30. I'm going to come down here and say 12 and 30. They both have to be negative because they have to be the same sign since we added up, or we multiplied to get a positive. And they're both negative because this is a negative down here. Sounds good so far. We added them, got negative 42, multiply them, get 360. Okay, it all checks out, which means I'm ready to simplify these fractions. I can say, if I had the fraction 9k over negative 12, what I would do is I would divide the top and bottom here by 3, and I would get 3k over negative 4. What if I had this fraction 9k, I want to do this in blue though. What if I had the fraction 9k over negative 30? Again, I would divide the top and bottom by 3, divide by 3, divide by 3, and I get 3k over negative 10. And I think I'm ready. So I still have this 6 factored out, and I also have the red, I'll do this in red, it's going to be 3k minus 4. And in black, I have this 3k minus 10. And as a sanity check, making sure -10 times -4 gives us +40. That probably means I'm correct. I only do a quick little check like that. I don't do the full check. And I think that's the right answer. All right, number 13. Okay, lesson 7-7 was really easy if you know the shortcut. That's why I put 4 problems on here. These are all 2 pointers on the actual test because of how low points they are. There's no work. You just know you're going to take the square root, and it's always going to be something plus the other and something minus the other, and you're ready to go. Well, the square root of b squared is b. The square root of 81 is 9, and then you just copy this, b and 9, and you get your final answer. So you're always jumping to the final answer. This is a difference of, it's a conjugate pair. That is the official name of this. There's these 2 things, therefore they're a pair, and conjugate just means one's a plus, one's a minus on the inside. Conjugate pair always multiplies to a difference of squares. Notice that's a square and that's a square, and there's a difference, which means it's the same pattern. 13, 14, 15, 16 on the actual test are going to be the exact same way. So again, you're going to have these 2 things being multiplied. One of them is plus, one of them is minus. It doesn't matter the order either. You can say this one's a minus and this one's a plus. And square root b squared, and you get b. b square root of 36 is 6. Make sure your b's and 6's look different. There's our final answer. It is that fast, that easy. All right, and number 15, it's a little bit harder because you're like, oh yeah, you just square root, and oh my God, you get a square root of 2. It's not okay. That means we were supposed to do the GCF, the greatest common factor first. So in here, we're going to divide by 2, which means I have a 2 factored out, and when I have a 2 factored out, I have an x squared left over and a minus 16 left over, and now I can say there's going to be 2 things after that 2 is factored out, where again, I'm going to do this in ink. I'm going to square root that. I'm going to get an x and an x. I'm going to square root u and get a 4 and a 4. One of them is a plus, one of them is minus. Again, order doesn't matter, and I get my final answer. That one required a little bit of work, but still, I'm going to make that a 2-pointer. 16, can I factor out any number? No, I can factor out a 3, but that can't be a 3, so can't do anything really. This one, just jump into the square root each of them, right? It's a little bit harder, but you can still do it. Square root of 9 is 3. Square root of y squared is y. And one of them is going to be a plus. One of them is going to be a minus. So I have a 3y again. And what about this one? Square root of 25 is going to be 5 and 5. The square root of x squared is x and x. And I'm done. They are that easy. All right, number 17. That is the multiplication chart. Number 17. Solve each equation by taking square roots. All right, well, the general idea here is just shove everything to the other side. So this 3, you, sir, madame, have to move to that side. We're going to subtract 3, and I'm going to get r squared is equal to 16. And then from there, I'm going to square root both the left side and the right side. Remember, when you do that, you technically have to do a plus or minus to give you the power to undo. So you can now undo because we have the power with the plus or minus, and r is equal to plus or minus. Well, what is the square root of 16? Square root of 16 is 4. So the answer here is -4 and +4. You can write it this way, which we do in class, but I think the answer key is probably going to do something where it has like a -4 and +4 for its solution set. I don't care what you use, but this one is what we do in class. So smiley face goes for you. Number 18. Again, we need to isolate this n squared, so get rid of this 2 first. The way we undo multiply by 2 is to divide by the 2. Divide by the 2 on both sides of the equation, and n squared is now equal to just a -20. And that's unfortunate. I guess it doesn't really matter, but I don't like taking negatives with square roots because it makes your answer imaginary, but that happens sometimes. So square root that side, square root that side, which isn't powerful enough to undo the square yet, but now with plus or minus, now we're powerful enough to undo, leaving me with n is equal to plus or minus the square root of -20. I'm leaving it like that because you need to do some things to it. The first thing that I see is it's negative, which is not okay, meaning it's going to pop out and become just an I. So n is equal to plus or minus I square root of something. And before I make that square root, let's go ahead and make a factor tree for the square root of 20. I'm pretty sure it can be reduced. The square root of 20 is the square root of something times the square root of something. Mainly it's 4 times 5. And the square root of 4 is 2, so our answer is going to be 2 square root of 5. So, and I guess I can reverse these two, so I can really say, let me say 2, whoa, that's too big. We can say 2i, and then square root of 5. It doesn't really matter, but that's typically the way that I like writing it. So 2 really big tricks, new things between 17 and 18. And number 18, we had a negative, meaning we had an I, and we also had a reducible square root, so know how to reduce your square roots. Number 19. Oh boy, lots of things happening. I'm going to get rid of the 2 and then get rid of this -3. Reason being, the order and why I'm doing that, PEMDAS. Please excuse my dear Aunt Sally. We're solving, which means we're going from the bottom to the top. Do we see anything that we can undo using addition and subtraction? If I use subtraction, I can undo the 2 because I can do minus 2 on both sides of the equal to sign, and that'll give me a negative 3a squared is equal to a negative 237. And again, these are the same sign, therefore you kind of added the 2 and the 5 to get a 7. Taking the sign larger always, and it's going to be a negative. From here, I do need to get rid of this minus 3, which is being multiplied by the a, which means I need to undo multiplication, and using a different color, like blue, I can divide by that negative 3, divide by the negative 3, and a squared is equal to, well, I mean, a negative divided by a negative is a positive, so I don't have to write a sign up front. But how do I do 237 divided by 3? There's a cool little tricky way that I want to do it. I'm looking for a number that's really close to 237, like 210. 210 divided by 3 is the same thing as 70. And then I need another 27 over 3, which is going to be 9. So the answer here is going to be 79, I think. Let me just double check this math. 210 is 70, and that means I have another 27 left over. Yeah, that makes sense. And then from here, I'm going to square root both sides, which isn't powerful enough, but once you have the plus or minus, then it is powerful enough, and cancel, cancel, cancel. A is equal to plus or minus the square root of 79. Can 79 be reduced? I am not sure. It can't be divided by 2. Can it be divided by 3? Let me just go on an expedition here. I might be doing this needlessly. It might not be able to be reduced. But let's see. Square root of 79. Could you do square root of 3? Here's how you can check for divisibility by 3. Take the digits 7 and 9, add them together. 7 plus 9 is 16, and then the number 16, add them together again. I get 7. 7 is not divisible by 3, therefore 79 is also not divisible by 3. It can't end in a 5. Could it be divisible by 7? No, because that would be 77, 8, 9, 10, 11, 12, 13. 13, I don't see a 13 going in that. It would have to end in a 3. I'm pretty sure that's a prime number. So I'm going to go ahead and erase that. I just went through my thought process. I divided 79 by numbers 1 through 13 in my head, and I couldn't get it to come out to any whole numbers. So I think that's our answer, plus or minus root 79. Good. All right, on to number 20. By the way, in the clock it says 3:03 in the top left. Once it hits 3:14, I'm going to go ahead and stop the video roughly around there, maybe a little bit before that, so I can let the video compile and upload to YouTube. Solve each equation by factoring. So again, this one is a nice easy factoring problem because none of them can be divided by a number, so there's no GCF. And this number is 1, which means we have a simple ninja star. Our ninja star, we add up to the middle number, mainly -6, the coefficient of the middle term, I should say, and we multiply to -16. This is the multiply number. So what times what is 16? This is such a low number that you can do it in your head. Like 1 and 16, nope. 2 and 8, yep. So 2 and 8 are the numbers. Why did I know that worked? Because since this was a minus sign, I was thinking what two numbers subtract to get about 6. The negative we'll figure out at the very end. And 8 minus 2 is 6. So from there, I need to say my answer was negative, which means the bigger number needs to be negative 8. And I can say that I had n minus 8 times n plus 2 is equal to 0. So what I've done so far is I've taken u and I've gone to u. The 0 didn't change. I still have the 0 on the right-hand side. And now I'm going to use the zero product property to say u can be 0 or u can be 0. Either of those are solutions to our equation. I can say that n minus 8 is equal to 0, or I can say n plus 2 is equal to 0. And then from there I can add 8, minus 2, and n could be -2 as one of my two answers, and n could be +8 for my second of my two answers. What about number 21? Number 21, again, I have no GCF. Ooh, maybe I have a GCF. I need to move u over here. I need to be able to use this zero product property, namely something times something else is equal to 0. And if I don't have a 0, I can't use the zero product property. So I'm going to add 6 to the left side of the equal to sign, add 6 to the right side, well, left and right side. Just do it to both sides. And I get 7x squared plus 18x plus 8 is equal to 0. And I'm asking myself, can I divide each of these by a number? Sadly, this 7 is a big prime number relative to this unit. 7 and 18 are co-prime. So I can't divide by any GCF. I just got to send it. All right, so let's do an advanced ninja star. Advanced because this is a 7, not a 1. So advanced ninja star, I'll do this off to the side. What two numbers add to the middle coefficient, 18, and multiply to these two first and last coefficients, multiply together. Sometimes 8 is 56. So what times what is 56? You can do this in your head, or you could use a multiplication table. 56 looks for 56 on the multiplication tables. So over here. What do we got? I got a 56, I got a 56, I got a 56. Those are the only three that I see. And there's 1 times 56 that I think will be unhelpful. What are we doing with the 56s again? We are trying to add them. Why add them? Because there's a positive here. Add them and get 18. So add them and get 18. 7 and 8 add up to 15. Nope. 4 and 14 is 18. Oh, that's what we want. We wanted 18. So, wait, what were those numbers? Is 4 and 14. So I come back down here and say, our numbers down here were 4 and 14. And everything is positive. You're positive, which means you're positive, and you're positive. There's how we factor it. We can, oh my goodness. I didn't set up my advanced ninja star correctly. I need to move down this 4, move down this 14, and finish setting up my ninja star correctly and say this is a 7x and a 7x. And now I can reduce. So there's no GCF, so there's no number out front. This fraction can't be reduced. 7 and 4 are co-primes. I'm going to say 7x plus 4. And what about 7x and 14? These are not co-prime. You can divide both of these by, and let's use a different color to make it really pop. I can say divide the top and bottom by 7, and I get 2x over, why did I say 2x? I don't know. It's really x, just 1x over 2. I was getting ahead of myself, and I saw the 2 down here, I think. So x and 2 means I have an x plus 2 here, still being set equal to 0, and then I can use the zero product property. Either 7x plus 4 equals 0, or x plus 2 is equal to 0. Be careful here. Warning, warning. If you just jump and say, hey, the answer is -4, you have made a mistake because you forgot to divide by 7 at the very end. That's why I do this long process over and over again, because I don't make a mistake if I do the thorough process. From here, we're going to minus 2, and x is equal to -2. You're right, you can use a shortcut on that one. You cannot use a shortcut on this one, just be like, it's the opposite of that last term. Because you're going to subtract 4, and you're going to get 7x is equal to -4. And then from here, you need to divide by 7 to get x by itself, and x is equal to -4/7, which is definitely not -4. And those are my two answers for number 21. Moving on to number 22. What do we have here? Ooh, okay, so again, we want to use the zero product property. So you, madame, need to move over here. Notice that the x squared and x squared are like terms. So when I subtract my 8x to move it, minus my 8x squared, minus my 8x squared to both sides of my equal to sign, you are now 0 on the right-hand side. I still have a 42. I still have a minus 54x. And I still have an x squared, but the coefficient changes to a 12. Please let us have a GCF. Please let us have a GCF. And yes, we do. Okay. We can divide each of these by a number. Definitely by 2. Can we multiply by 4? No, that would be 44 here. Can I multiply by 6? 6 times 7 is 42. 6 times 9 is 54. Yeah, so I can divide by 6. Let's go. All right. I'm looking for the biggest possible number. I think 6 is the greatest common factor. So if I factor out a 6, I'm left with a 2x squared minus 9x plus 7, and that's set equal to 0. And then I'm going to factor this with an advanced ninja star. Advanced because I have a leading coefficient other than 1 here. So here's my advanced ninja star, 2x and 2x. That's my mistake from my last problem. I'll make that, or avoid that mistake right now. They need to add together to get -9. They need to multiply to get, again, 7 times 2 is 14. And this is a small problem, so I can do it on my own. Again, this is a positive times a positive, which is a positive. If this number up here is a positive, that means I'm really adding to get this 9. Again, ignore the negative for now. What two numbers added together get 9 and also multiply to 14? Well, 1 and 14 does not add to 9. 2 and 7 multiply to 14 and add to 9, so it has to be 2 and 7. 2 and 7, okay. So we need to make sure that this sign and this sign match. That's how we get a positive. And they also add to a negative, which means they both have to be negative. And then I reduce the fractions. I can divide the top by 2, divide the bottom by 2, and I get x over -1. And I cannot reduce this fraction, so I leave it 2x and minus 7. So let's write our final answer. We still have a 6. Well, it's not a final answer. It's a step in solving this using factoring. And I have an x minus 1, and I have a 2x minus 7 being set equal to 0. I'm going to do some fancy magic. Divide that side by 6, divide that by 6, and you're gone, and you're still 0. Which means we could ignore the 6. Really, our problem becomes this. It becomes x minus 1 times 2x minus 7 is equal to 0. And then I can use the zero product property saying that x minus 1 could be 0, or 2x minus 7 7 could be 0. Either of those are going to be answers that will get us to 0. So from here, add 1, and x is equal to positive 1, which is one of our two answers. To get the second of the two answers, we need to add 7 to give us 2x is equal to 7. And then finally, we need to divide by 2 to get x is equal to 7 halves, or if you want 3.5, if you like decimals. Cool, that is number 22. How close to solving? I have a few more problems left. So it's 3:11 right now. I'm gonna go ahead and finish the second part of this video tomorrow. And I think it's just these 2 pages, and then there's the answers. I'll show the answer right now just in case I made a mistake. If you catch a mistake, like always, you get some extra credit and you can log in the extra credit tracker, as long as you let me know that you found it so I can maybe make the fix for later. Thanks for watching. Good luck on the test if you're about to take it. I'll see you guys later.